We know that a current carrying circular loop produces a magnetic field. This magnetic field is similar to the magnetic field due to a magnetic dipole. This magnetic field is also similar to the electric field due to an electric dipole. Now, let us study the magnetic induction at a point on the axis of the circular current carrying loop and compare it with the magnetic induction at a point on the axial line of a magnetic dipole. Let us compare this magnetic field with the electric field strength at a point on the axial line of an electric dipole. We have learnt earlier that the magnitude of the net magnetic induction at a point on the axis of the circular loop at a distance x from the center of the circular loop, BA is equal to mu naught IR square by 2 into R square plus X square whole power 3 by 2. Let this be equation 1. The direction of the field is along the axis of the circular loop. When the distance from the center of the loop to the point P is far greater than the radius of the circular loop, that is, x is far greater than r, the term r square in the denominator may be neglected. Now the equation 1 is transformed to BA is equal to mu naught IR square by 2x cube. On multiplying with pi in the numerator and the denominator, we get BA is equal to mu naught by 2 pi into I into pi r square by x cube. We know that the area of a circular loop A is equal to pi r square. On substituting A for pi r square in the equation, the magnetic induction can now be written as BA is equal to mu naught by 2 pi into IA by x cube. We have learnt earlier that magnetic moment of a current carrying loop is the product of the current passing through the loop and area of the loop, that is, M is equal to IA. On substituting the magnetic moment, we get the magnetic induction at the point P on the axis of the circular current loop. BA is equal to mu naught by 2 pi into M by x cube. By multiplying with 2 in the numerator and the denominator, we can write the magnetic induction at a point P on the axis of the circular loop as BA is equal to mu naught by 4 pi into 2m by x cube. Let this be equation 2. Now, let us compare the magnetic induction along the axial line of the circular current loop with the field strengths of the magnetic dipole and the electric dipole at points along their axial lines. We know that the magnetic induction along the axis of the circular current loop, BA, is equal to mu naught by 4 pi into 2m by x cube. We know that the magnetic induction at a point P on the axial line, at a distance x from the center of magnetic dipole, BA is equal to mu naught by 4 pi into 2m by x cube, where m is the magnetic moment of the dipole. We also know that the electric field intensity at a point P on the axial line at a distance x from the center of electric dipole, EA is equal to 1 by 4 pi epsilon naught into 2 PE by x cube, where PE is the moment for the electric dipole. Let this be equation 3. The magnetic induction at a point P on the axis of a circular current loop is exactly the same as the magnetic induction at a point P on the axial line of a magnetic dipole. Compare equations 2 and 3 to notice that mu naught is analogous to 1 by epsilon naught. This depends on the medium where the electric dipole or the magnetic dipole is placed. M is analogous to PE. That is, the magnetic dipole moment is similar to the electric dipole moment. Also, BA is similar to EA. That is, the magnetic induction is similar to the electric field intensity. Now let us compare the magnetic induction at a point on the equatorial line of a magnetic dipole with the electric field strength on the equatorial line of an electric dipole. Using the comparison, let us arrive at an expression for magnetic induction at a distant point on the plane of a current-carrying circular loop. We know that the electric field intensity on the equatorial line of an electric dipole at a point which is at a distance x from the center of the electric dipole, EE is equal to 1 by 4 pi epsilon naught into PE by x cube. Let this be equation 4. Here, the distance x of the point is much greater than half the length of the electric dipole. Similarly, in case of a magnetic dipole, the magnetic induction at a point on the equatorial line at a point which is at a distance x from the center of the magnetic dipole is BE is equal to mu naught by 4 pi into m by x cube. Let this be equation 5. Here, the distance x of the point is much greater than half the length of the magnetic dipole. Let us make use of the similarity in the relations we have arrived at. While we mapped the magnetic induction at a point on the equatorial line of a magnetic dipole and electric field strength at a point on the equatorial line of an electric dipole. Mu naught is analogous to 1 by epsilon naught. M is analogous to PE. That is, the magnetic dipole moment is similar to the electric dipole moment. And BE is analogous to EE. That is, the magnetic induction is similar to the electric field intensity. Substituting these similar values in equation 4, we arrive at the magnetic induction at a distant point P on the line which is in the plane of the circular loop as BE is equal to mu naught by 4 pi into m by x cube. Here too, the distance x of the point is much greater than the radius of the circular loop. Observe that the magnetic field produced by a current-carrying circular loop is similar to the magnetic field due to the magnetic dipole at large distances. Such a dipole is referred to as a point magnetic dipole.